All right, so if you guys remember in the previous session, we have actually calculated the abstract of excavation and then the PCC work in the foundation, okay? But over there, as you can see, for the column, it is newer excavation, okay? Its columns PCC, you can say, and then the columns PCC, its height is, you can say, 6 inches or 0.5, okay? It was just a correction you guys have to make. You can see because it is 6 inches, but in the walls foundations, you can see we have 9 inches PCC work. Okay, so it was just a correction. Now, next, we will have to determine the brickwork in the foundation, where we have actually two steps. Okay, you can say this is step one, and let me just see its dimensions. You can see this is 2 feet and 6 inches. Okay, step one's width, and then we have step two, whose width is, you can say, 2 feet. Okay, so we will actually calculate the brickwork. Okay, and this is number three, and I'm gonna say brickwork in foundation. Okay, and that is of course 1:3 mortar. Okay, in the same brickwork. Now, the brickwork can be different for the long walls, for the short walls. I'm not going to copy the columns because there is no brickwork for the columns, okay? So long walls, short walls. And again, remember, the numbering can be the same, okay? Very simple. Because we have the same number of long walls, the same number of short walls, and there is a brickwork for each, okay? Wait a minute, what's wrong over here? Okay, column, that is one, so I'm going to remove the one for the column. The length can be different, okay, because these lengths, like you can say 27.79, it was for the long walls one length, but for the excavation, okay, the excavation length can be more lengthy, you can say. However, for the step one, you can see this is step one. Its length can be little bit, you can say, smaller, or maybe the foundation was lengthy, okay, with respect to this step, okay. So step one, you can say, let me just have some annotation so you guys can see it, okay? And I'm gonna just uh, do it a little bit quick, like you can say, we have step one, I'm gonna call it, okay? Step one. This is step one, and then we have the other one that is step two. And above this, we have DPC, okay? So we're gonna also look into that. Now, if I can separate it, like let's say here is a line, okay? So this is the separation for step one and two. And there is, let me just annotate them so it can be very clear for us, okay? This is 2 feet and 6 inches in width, okay? Step one. So let's just see, for each wall, we have two steps. This is now the problem, okay? There is two steps for each wall. And that's the problem. Now, you can see long wall one, we're going to insert some rows for that. Like maybe insert one row and insert another row because we have two steps. Like you can say step one and then brickwork step two. Very clear, okay? And similarly, we will apply the same process for all, but let's just look into the same thing, okay? Like you can say long wall. Now, in number, there are only three, okay? But I'm going to remove that one because we are calculating the things for the steps. Step one, that is 3 in number. Step two, that is 3 in number. But in the length, let me just, you can say, lock this view so we can have actually data on the top. Oops, just a minute. I'm gonna lock this one. I mean freeze, okay? Now we can see that, it's clear. So we will have to determine the brickworks, and as you can see, step one for the long wall one. The length, what should be the length? We will apply the same formula, okay? Now, the length for each wall, of course, they are over here. You can see them. It's from the drawing. We have already separated them. You can see in the previous session. Okay, long walls, short walls. Okay, we have split the same 2D plan into long wall, short wall. But we will actually determine the length by the same way as we did for the excavation. Like we will subtract the thickness of the wall from the width of the foundation, which is actually the width of the step one. So it means step one's width minus the thickness of the wall. And then we will, of course, add the length of the wall, which is just, you can say, in the plinth level. Now, the step one, that is 2 feet and 6 inches. Okay, if I'm not wrong, let me just confirm it again. It is 2 feet and 6 inches. Okay, that is step one. We will actually subtract 9 inches from it. Very simple. Like you can say 2.5 minus 9 inches, which is 0.75. Okay, that is, oops, we have taken 25. Okay, it is 2.5, and we will actually subtract 0.75, which is 9 inches. Okay, so it is 1.75. Now we will add the length of the wall. Okay, and that is actually the length of the long wall 1, which is 25.291. Okay, so 25 plus 25.291. So this is actually the total length for step one, which is 27.01. Okay, so you can say we're here, I'm gonna write 27.041. 041. This is the length. Now the width, that is known, okay, 2.5. If you see from the section, the height, let's just see what's the height. It is 6 inches. You can see it over here. Okay, so this is 6 inches, and I'm gonna put it over here like maybe 0.5. Very simple. And we will apply the same formula over here, copy from the above, and you can confirm it by double click. As you can see, it is just indicating that the formula is okay. Now the as you can see, long wall 1, okay, and these things are actually in step 1 and step 2. Okay, again, let me just remove this thing, and actually I'm gonna copy these, or you can even move them, because okay, so this is going to be in CFT. Okay, and similarly, we will determine the length for the step 2, and we will follow the same process. Okay, how? Let's just see it. Okay, for this, let me just erase this of it, and as you can see, for the step 2, that is, I think, 2 feet, if I'm not wrong. Okay, let's just confirm it. It's 2 feet. Okay, the width of the foundation, or maybe the width of the step 2, that is 2 feet. We will subtract the thickness of the wall. Very simple. Okay, so it means 2 minus, where is it? 2 minus the thickness of the wall, which is 0.75, and then of course we will add the length of the wall 1, which is, you can see it over here. Okay, and that is 25.22 minus 0.75, and then we will actually add this length, okay, which is plus 25.291. So this is the length for the step 2, which is 26.54. Okay, very simple. So we have the length, and it is, where is it? Over here, 26.541. Okay, now the width, that is actually 2 feet for the same step. For the step 2, the height is, let's just confirm the height. It is, you can see, 9 inches. So we have 0.75. Clear? Now we will actually drag the formula below, and of course this is gonna be in CFT. Very simple. Now we will apply the same process for the long wall 2. Okay, and let me just insert some 2 rows, because we have 2 steps. Okay, and similarly we will have actually like step 1 and then step 2. Let me just copy them and paste them over here. Now the thing, as you can see, the width and the height for both can be the same. Okay, so I'm gonna copy them over here, and of course the numbering can be the same. Okay, not the same, because we have long wall 2, and we will actually confirm that from the long wall 2, because their numbers are only 1. Okay, you can see it from the other you can say examples, like maybe from the PCC, we have long wall 2, and it is 1 n number. It means their strips are 1 1. Okay, the thing which is actually important is the length of long wall 2. Okay, and we will apply the same process. And let's just jump into the AutoCAD again. Now we will actually have to subtract the thickness of the wall from the thickness of this step 1, and we will add the length of the long wall 2. Very simple. Okay, it is the same process. I'm gonna do it for the all, right? So the step 1, it was 2 feet and I guess 6 inches. Yes, 2 feet and 6 inches. Okay, so 2.5 minus 9 inches, which is the thickness of the wall, and we will add the length of the wall, okay, and that is of course 13.125. And even you can confirm it from the drawing, okay, which is 13.5. Where is it? Yes, it's over here. 13.125, okay. Plus we will add 13.125, and that is 14.875. 14.875, okay. Now for the step 2, we will apply the same process, okay. Like maybe you can say the step 2's width, that is 2 feet. We will subtract the thickness of the wall, which is 0.75, okay. And then of course we will add length of the wall, which is of course 13, oops, wait a minute, 13.125. So 14.375. 14.375. That's very clear. Now we will apply the same formula. You can even drag them and remove the zero because there we don't have videos. And of course the CFT work. Now we have done actually the long walls, like long wall 2, long wall 1. Okay, they are done. Now we will actually calculate the brickworks quantity for the short walls. Okay, and here's only just a simple trick. If you see, we are adding the length of the wall over here, okay? And even you can see in the description, as you can see for the long walls, we are subtracting the foundation width, okay? I mean, we are subtracting the thickness of the wall from the foundation width, and then we are adding the length of the wall, as you can see. But this time, this ratio will be subtracted from the length of the wall, okay, for the short walls. So let's just see, and we will actually have the same process. We will insert some rows because we have 2 steps, okay, like step 1 and step 2, and step 1, and then of course step 2, and we are applying this for the all, okay. And similarly for the short wall 4, you can say step 1 and step 2. And this is actually to make it easy for all, okay. And of course step 1 can be 3 because we have short walls in number, those are 3. Very simple, okay. And they are 2, and of course the short wall 3, those are 2 in number, so their steps must be 2 2, and here we have 1 1. Very simple. What matters is actually their lengths. However, their widths or maybe the heights remain the same for all because we have only one section for long wall and short walls as well. It's very clear. Now let's just calculate the length of step 1, okay, for the short wall 1. And this is going to be very simple. We will only subtract actually the thickness of the wall from the width of the step 1. And then of course we will subtract that ratio from the length of the wall. Very simple. Like, let me just switch this thing in such a way so we can see it, okay? Now, we're here, let me just zoom in this portion. The step 1, that is actually 2.5 in width. And let me just have some remarks over here. The length should be, for step 1, that should be actually the length of the wall, which if you see, that is, if I can see it, here is it. Okay, short wall 1, that is 11.25. Okay, so that is actually 11.25. We will actually subtract one thing, which is actually the step 1's width, okay, and that is 2.5, and subtracting the thickness of the wall, which is 0.75. And this is actually the same formula, okay, we are applying. And you can have calculator, or maybe you can even enter those things in the same Excel, okay, to calculate the formula. Very simple, okay. And just by doing the equal, like maybe if there is equal sign over there, and it will calculate that for you, which is 9.5, okay. So this is the process, okay. By Control Z, it means this is 9.5. And we can actually put this video in the same cell for the length, okay? We're here. This is the length, which is 9.5. Is it clear? And let's just calculate that for step 2, okay? Again, in the remarks, the length should be, let's say the length for step 2 should be, we will have actually the length of the wall, which is 11.25, okay? And we will subtract 2.5, which is, 2 which is the weight of the step 2, and subtracting the thickness of the wall, which is 0.75. Very clear, okay? So this is going to be the length. And by applying the same formula, Excel will do that for you, which is going to be 10. Okay? Very simple. So we can use 10 over here, and that is in reverse. Okay? The length should be 10. All right. We will have actually their beds, and they are known, which is 2.5. And then for the step 2, that is 2. The heights are different, that is 0.5. And this one is 0.75. And actually for the quantity, we will drag the formula below so you guys can see it. Okay. And of course, the CFT, they are going to be in CFT. All right. We have actually done short wall 1. Now we will cover short wall 2. Okay. And this is going to be the same process. Let's just copy these things because these are just the same for all. So we can have much time in order to solve these things. Okay. Okay. Can be copied over here and maybe for wall 3 and maybe for wall 4 over here. Okay. So what we have to do is actually to determine the length, and the formula will work actually the same thing for you. Step 2 length, we will have to just do it over here, let's say. Okay. Over here. Now, what should be the length? Of course, for the wall 2, we will actually look for the length over here, okay, for the short wall 2. That is 12.375. 12.375, okay. So 12.375, this is the length of the wall. We will actually subtract for the step 1, okay, and that is 2.5. We will subtract its weight, and of course 0.75 for the thickness of the wall, okay. And even we can actually put the formula over here, okay. So this is going to be the length, so equal, and this is going to be 10 point something, right? Very simple. Now we will apply the same process for the remaining, okay, 10.625. Okay, I'm going to remove the formula and I'm going to say 10.625. So the formula remains the same, okay? And this is very simple, okay? And let's just say, again, we will have equal, and we have the total length is 12.375. And we are subtracting actually the weight of step 2, which is 2 this time, and 0.75. And this is going to be 11.125. So let's say 11.125. Now we will put these videos in the same thing over here, like, okay. So we have the length for the step 2 for the short wall 2, that is going to be 10.625. And over here, it should be 11.125. And as you can see, this is actually the same quantity. Now I'm going to switch the video so I can apply the same thing for the remaining, because the video can be then longer. Okay, so I'm going to pause the video and then we will start when I'm done with it. Okay, now I have calculated the lengths for step 1 and step 2, and that for the short wall 3 and short wall 4. Now I'm going to copy actually the same CFT work, okay, just like that, okay. And let's just remove this thing, and this one, of course, these zeros. Okay, so this is actually the total brickwork. Now we're going to add them over here, okay. So we can, let's say, we will select these things with extra cell, and then by this sum over here, we will click that. As you can see, let me just say we have the total brickwork over here, total brickwork, okay. Very simple. But however, we will actually deduct some quantities for the doors, for the windows, etc. So it means this is not the net work. This is the total brickwork. We will have to subtract the deduction, and then of course we may get the net brickwork. And this is of course 1, 3, okay. That is the ratio for the mortar in the same brickwork. Now let's just have some deduction, okay. Deduction of our brickwork and foundation. You should include foundation over here, okay, in foundation. Okay, the thing, as you can see, we have foundation. It means there is no deduction, because in foundation, we may not have, you can say, the brickwork detection because there is no door, there is no window in the foundation. Okay, so it means that's okay. We're here. I'm not gonna count it. And even let me just remove the total. So it's better to actually calculate or maybe include the ones, and then maybe we should add them all. What do you say? Okay. Now, we have actually done the shortfall 4. Now we will have to determine the quantity actually for the walls. Okay. And then we will actually calculate no matter the DPC. Okay. For the walls, as you can see, the length must be the same, only the thickness is just different. And of course, the height that is 11 feet. All right. So let's just say the brickwork in walls. Brickwork in superstructure, you can say, or maybe in walls, okay? And that is also in 1:3. Now, remember, these are the same thing, long walls, short walls. They never change. However, and in number, let's say one thing, that is number 3, and we're here, we have number 4, okay, in serial number. Okay, these things remain the same, okay? And I'm even gonna copy their numbers, okay? We're here, their numbers like this. Now, their length matters, of course. If you see, we have these lengths, and let me just place them over here so we can see them directly. As you can see, we have long wall 1, and they are 3 in number, and their length is actually 25.291. For the long wall 2, its length is 13.125. For the short walls, their length is, of course, you can see 11.25. Okay, 11.25. And for the short wall 2, that is 12.375. For the short wall 3, that is 6.158. And then lastly, we have 5.625. So these are the lengths, and they are actually taken from the same drawing. Okay, you can just watch the session 1 in order to learn these things and how these lengths were there in Excel. Okay, so as you can see, we have long wall 1 just for the example, long wall 1, and they are 3 in number because we have 1 over here, this is 2, and this is 3 because they are same in length, and their length is just given over here, 25 feet and 3.5 inches. Okay, which is of course total in feet, and that is 25.291 feet. Very simple. Okay, now the width can be actually the same, like maybe a thickness of the wall, which is 0.75. That is known. Okay, you can see it from the same drawing over here. The wall thickness, that is 9 inches. Okay, so I'm gonna just apply that to all. And another thing, which is the height, and that is 11 feet, the height of the wall. Okay, let's just provide that to the all. Now let's just copy one formula from this point, and here I'm gonna paste the formula, and let's just drag the formula reply to the all. And this work is of course in CFD. Now we will actually add all the brickwork to have the total brickwork quantity, you can say. Okay, so select with extra sheet and cell, I mean. Okay, select with extra cell, and as you can see, we have 1800 and 3.5 something CFT brickwork. Okay, so this is the total brickwork, and that is in 1:3. Very simple. Now another thing is actually to have detection for the doors, windows, and ventilators, you can say. Now, there can be number of doors, windows, and ventilators, and we have to actually look for that in the same legends over here. We have some legends. Okay, so we have different windows, like maybe window 1, and its size is 5 times 5, and they are 5 in number. So I think I should let's just take its screenshot so we can see it then. Okay, let's just take a screenshot. Very simple. From this, I'm gonna take a screenshot, and as you can see, they are now over here with us. Okay, so we can have the detection process in short time. Now zoom in. Okay, we're here. Now, as you can see, we have W1, then we have V1, then we have D1, like maybe door 1, there is door 2, we have door 3. Okay, this is detection we have to do. Now, in number, they are 5, then 1 and 1, and then of course 2, and then 1. Okay, for door 3. It means window 1, that is 5 in number. And let me just confirm it, it's good or not, if it's working or not. Okay, from the layer, I'm going to switch the thing, which is, of course, the long wall and short walls. Okay, so you guys can see it. This is short wall and here is long wall. And this is long wall. Okay, and now let me just see the doors and windows. As you can see, let me just have text over here. And text is already over there. Okay, as you can see, this is the window. Okay, so we have one, there is two. Okay, and here three, this one is four, and this one is five. It means we have five doors, windows one, sorry. This is window, okay? And they are actually 5 by 5. The size is just 5 by 5, okay? You can just confirm it from the drawing. Let me just confirm it from the elevation, okay? Just like that. Okay, this is 5, its width is 5, and then the height, that is also 5, okay? So it means the data is just fine, and we have to actually put a size, okay? Like maybe the in front, the area is just 5 by 5, okay? So 5 by 5, and we will take the thickness, and that is actually the thickness of the wall, the same thing, okay? And this is going to be the same for all. The size for V1, that is actually 1.5 times 1.5. And then, of course, for D1, that is 4 times 7. For D2, that is 3.5 times 7. And then, of course, for D3, that is 2.5 and 7. Now, this screenshot is no more needed. I'm going to delete it. Okay, let's just apply the same formula for the all, okay? Just multiplying these 4 columns and apply that. And that they can be in CFT because it is just brickwork, or you can say the volume. And now let's say detection for lentils. And I'm gonna do this brickwork today, and then we will end the session. And of course, we will start from the same point tomorrow. So deduction for lentils. Now it depends how many lentils do we have. There should be lentil on the doors and windows only. Very simple. Now I think I should need the same screenshot again so we can do the work very easy, okay, in short time. So let me just have the same screenshot. Just over here. And one another thing is, let me just decrease its size. Now, lentil can be actually in different size, and let me just jump into the same AutoCAD. As you can see, let's say if we have this window, okay? Now, we will have lentil, which is, of course, let me change the color. Let's say the lentil can be in this form, okay? Maybe some bearing, okay? And the length of the window can be added, okay? So this is called the bearing over here, okay? The overlap on the window. So bearing can be added to both sides. It means this is going to be the length of the lentil. And however, the thickness of the lentil can be taken from over here. That is 9 inches. And of course, its width is 9 inches. Okay, very simple. I guess there is something which is needed over here, like maybe lentil for W1 or window 1. And there we have lentil for D1, door 1. There should be lentil for D2. There should be lentil for D3. Now, in number, they should be the same thing as this one. Window 1, that is 5 in number. Door 1, I have just I were there. So door 1, that is 1 in number. Door 2, those are 2. And door 3, those are only 1 in number. Now, the length of the lentil can be actually something we will calculate actually from the size of these windows, you can say, indoors. Like let's say for the window 1, the size is 5 by 5. It means 5 is the length of the window. So we will add 6 inches for bearing for one side and another side. It becomes actually then 6 feet. Like 5 feet plus 6 inches plus 6 inches. That means 6 feet is going to be the length. Now for the D1 or door 1, as you can see, the length is just 4 feet. 1 feet can be added for the bearings for one side and another side. So this becomes actually 5. Now for the door 2, the size is 3.5. So it becomes 4.5 after adding the bearings. So 4.5. Now for D3, that is 2.5. Adding 1 feet for the bearings, it becomes actually 3.5. Now the lintel is just 9 by 9 inches. You can say 0.75, then 0.75. Drag the formula for all because it is the same lintel for all. It is never changed. I'm gonna delete the screenshot now, and we will actually apply the same formula for all, okay? And let me remove the zeros. And this is actually in CFT, going to be in CFT, you can say, okay? And now deduction for lentil is actually the same thing. You can just say the quantity of RCC work, okay? If there is RCC work, and let me just include one thing, okay? This is deduction, but this is RCC, lentil is just RCC, and I'm going to include the ratio as well, 1 to 4. You can say this is from the specification, okay? Now we will add the total deduction. This is the point, okay? So let's say we have total deduction, that is 193 CFT. And now let's calculate the net brickwork. It's going to be very simple, okay? So the net, now the formula is actually equal, and we have the total brickwork. It's over here, and we will actually subtract a deduction for the doors, windows, ventilators, and then for the lintels, okay? And enter. So this is the total brickwork, okay, in CFT. All right, is it clear? And I think it's okay for today. See you tomorrow. Allah Hafiz.